So for the lunar time-lapse videos, I've been using my Celestron mounts, this Nexstar SE mount and also the AVX mount, which is an equatorial mount. The Skywatcher mount is great, but one of the limitations is that you cannot select objects that are below the horizon. It will only allow you to select objects that are visible above the horizon. However, with the Celestron mounts, you can configure the filters to allow selection of objects that have not risen above the horizon yet. And I did that with both of these mounts. Now, this one is an alt azimuth mount, so it's quite good. It's a budget mount, but it's still quite accurate in tracking. However, you will notice in the time lapse that there is some movement, and that's because it's tracking using two axes. And on occasion, I had to realign slightly, and that was probably due to the fact that the mount was not perfectly leveled. But I took a bit more time in setting up the equatorial mount to polar align it correctly, and you'll see in the time-lapse video taken from this telescope with the Nikon D5600 connected to the back that the image is a lot more stable over a long period of time because this mount is tracking using a single axis of rotation, so there's less inherent error in the tracking. So I've got the mount powered up and I just did a sample alignment to Jupiter, which is visible now in the eastern sky in Sydney, Australia. But just to show you that we can select the moon, even though it has not risen yet. It's not due to rise for about another 2 hours. And it gives you a slew limit warning. So that's basically telling you that it's below the horizon, but we can override that. And it's now going to point to the direction where the moon is, and it will move automatically to meet the moon as it reaches the horizon. And that's what I did last night with both of these telescopes, so you can see the moon at exactly the moment that it rises. And there you can see the camera's pointing down. So in another 2 hours that camera would be pointing level and it will capture the moon as it rises. So the other thing I did was to set up the B700 in Star Trails time-lapse mode, and that caught a spectacular moonrise, which you can see here. It shows the star trails, then it shows the moon appearing. Now, this is giving us another excellent demonstration of how overexposure in the camera can produce the false illusion that the moon is getting larger as it rises. You can see just as it comes up, the image appears quite small, but as the moon continues to rise and become brighter, it actually appears larger in the video. Now that's just a false illusion, because if we go to the video taken with the other cameras, you'll see there was no change in size whatsoever. So switching to the P900 footage, which was on a tracking mount, taking one frame every 30 seconds, you'll see the mount was moving, and those first lights you see are just street lights while it was still pointing below the horizon. That's a tree in the distance, and then we capture the exact moment that the moon first appears on the horizon. So you can see it just there. Now what you will notice over the next few hours is that there is no change in the size at all. The brightness changes, and a couple of times I did manually adjust the exposure value in the camera, but from the moment the moon rose until several hours later, there is no change in size whatsoever. And yet, when the image is overexposed, it gives the false illusion that the moon is changing in size, which is not the case. So back to the star trail video, you can see that the trails are progressively more curved as we look further south, and that's because they are rotating around the south celestial pole. The camera was facing just south of east in this frame. Now you will also notice that as you look left in the frame, some of these trails are in fact straight. Now that's a vital piece of evidence to help us understand we are in fact on a globe, because if you are taking star trail videos facing east, there will be a line of trails that are in a straight line. And if we were doing this from the equator, that would be straight up and down. If we were doing it at 45 north or 45 south latitude, the straight line star trails would be 45 degrees from the horizontal. In fact, for any location on Earth, if you take these star trail videos looking east, the straight line star trails will be at an angle above the horizon that matches 90 minus your latitude. Another easy proof that you're living on a globe. So now I'll play the footage taken from last night, and the first one will be the time lapse, followed by the footage from the P900 attached to the alt-azimuth mount. And you will see it does move around a bit, and I do recenter it occasionally. And then the last clip will be the footage taken with the equatorial mount and the D5600 camera attached to the telescope. And you'll see, because the equatorial mount was quite accurately aligned, it jumps around a lot less. It's tracking much more accurately through the night. And the final thing to mention is that the timestamp on the P900 is accurate. On the D5600 it was still set to daylight saving time, so it's going to be 1 hour ahead. So it's Saturday the 7th of April, and I've just spent the last 30 minutes polar aligning my Celestron AVX mount. We are about 90 minutes before the moonrise, and as you can see, the Skywatcher ED80 telescope is angled downwards because I have the mount tracking the position of the moon. Now very shortly I will attach a camera to the back of this telescope, and it's a beautiful clear night, so we should have a good view of the moon as it rises.